Hello everyone, welcome to Engineering Explained channel. In this session, I am going to take basic thermodynamics model 3 lecture line, that is entropy. Here, this is one of the property of the thermodynamic system, and that property we have taken while discussing the heat, heat transfer, and in the second law of the thermodynamics also that property is comes for the discussion. And here, what is that entropy and how it will be considered for the system during the energy transfer we are going to discuss. What is entropy? Entropy is a measure of the disorder of a system or energy unavailable to do work. Here, the disorder of the system, the molecules, how those are arranged. Okay, if it is orderly arranged, then the entropy is less. If its disorderness increases, then the entropy will be more. And the disorderness will be more, then the energy available to do the work also more. And that can be discussed with the consideration of the solid and liquid gaseous phase of the substance. And in the solid, the molecules are well arranged and the disorderness will be very less. If the disorderness is less, entropy will be less. If that solid will be converted into liquid by phase change, then the molecules will be a random movement. Those will have the random movement and the disorderness will be more. Then thereby the increase in the entropy taking place. And further the liquid, if it is converted into gaseous phase, that is a vapor, then again the molecules will be move in the random way. Those will be away from each other. And the disorderness of those molecules will be increases. And that's why the entropy of a gaseous fluid will be more. And in this way, okay, in this direction, the entropy will be go on increasing, and in this direction, the entropy will be decreasing. Here we can say increasing the entropy and increasing the disorderness. In this direction, it will be decreasing. But here, one thing, any system undergoing the transfer of the energy, and during that time, the conversion of the one phase to the another phase and the change in the fluid of the system will be taking place. There the disorderness will be changing, there the entropy will be changing. Usually the entropy will be increased during the energy transfer, not decreases. It may be for the isolated system, it may remain same, but it will not decrease. Entropy will be increases. And that the further discussion we can take. Entropy is a scientific concept that measures the disorder or randomness of a system. The amount of energy unavailable to do work and the number of possible ways a system can be arranged. How the system can be arranged, that also considers the this entropy. It is a fundamental concept in a thermodynamics and is often described as a measure of the spread or disorder in a system where higher entropy corresponds to more disorder. The more disorder, then the higher will be the entropy. Then further moving, the key aspects of entropy. The disorder and randomness will take first that point. The entropy quantifies the degree of disorder in a system. That quantification of the degree of disorderness, that is measure of the that entropy. For example, transition from the solid where the molecules are neatly arranged. In the solid, the molecules are neatly arranged to liquid. From the solid to liquid, if the transition taking place, where the molecules are more chaotic, means those are free to move, represents an increase in entropy. If the molecules are chaotic and those are random in nature in the liquid, and thereby increase in the entropy we can see. Then energy availability concern, that how the entropy can be measured. A system with high entropy has a large amount of its energy that is unavailable to do useful work. Here the entropy is higher, then the large amount of its energy is unavailable to do the useful work, and that is called a system is having the more unavailable energy. For instance, a car's kinetic energy, the car's kinetic energy that is usually used to drive the car is converted into heat. Okay, in that kinetic energy, the rotational energy, what it is there, okay, that is converted into heat through friction. Okay, during the transmission, the whatever the energy is there, that rotational energy that is to be transmitted to the wheel. During that transmission, there the movement is there is a friction, and due to that friction, it will be some part of the energy is converting into heat, and that heat converted we cannot use as energy, that is dissipated to the atmosphere, and that's why that its energy becomes more spread, that part of the energy is more spread out, and higher entropy that is, and less available power to vehicle. If there is a friction, then that part of the energy is lost as a converting it into heat, and thereby less power is available to drive the vehicle. That is called as a unavailable energy. It is an example like this where the conversion of the energy, useful energy, into some other form where it cannot be used as the useful form of the energy, that is called as a energy unavailability, and that is the system which are having the higher entropy, those are having the higher energy unavailability. Further moving, information and statistics. In statistical mechanics, entropy is related to the number of possible microscopic arrangement. Number of possible microscopic arrangement, those are called as microstats. That means the molecules in the form of microscopic, we can see individual molecular level what the study is there, that is called as a microscopic, and those are the possible microscopic arrangement, the molecules arrangements what is there, that is that corresponds to systems of macroscopic state, the group of molecular states. The individual molecular level we are not going to consider as entropy, all the molecular group of molecular level we are going to consider that entropy. Here the microscopic arrangement what it is there, individual molecular level arrangement, that corresponds to group of molecular level arrangement state of the system, and that will be gives the entropy of the system what it is there. A state with more possible arrangement has a higher arrangement. More possible arrangement has higher entropy. That means if the more possible arrangement means disorderness, if it is a more, then higher entropy for that system. In thermodynamics, there the second law of thermodynamics states that the total entropy of an isolated system can only increase or remain constant over a time. It will never decrease during the energy conversion. In the second law of thermodynamics, we are going to convert that is a heat into a work, okay, and also transfer the heat from the lower temperature body to the higher temperature body by application of the heat. And there the entropy of an isolated system, energy and mass will be remains constant for that system. The entropy is increase or remains constant over time, it will not decrease. This means the systems naturally evolve towards a state of greater disorder. Naturally the system will be evolved towards state of greater disorder, means more disorder towards that the system will move, unless energy is used to decrease the entropy, unless the external energy if you use to decrease the entropy, otherwise naturally the entropy will be increases, the entropy will be increased if you use the external energy to order, there is a compress the gas to order more, have the more order of the molecules like that, the entropy can decrease by application of the energy, but naturally it will be increases. Applications, the concept of entropy is also used in other fields, not in the thermodynamics, other field also it is used, such as information theory, where it measures the uncertainty that is again the disorderness or unavailable energy it is there, or information content of the message, the information content of the message. like this. Here the this entropy, whenever the energy conversion is taking place, the entropy of the system will be gone increasing. Okay, one system to the system and the surroundings, the entropy, each the system entropy and surroundings entropy we can find, and also the universe together, system and the surrounding we are going to consider as a universe. The always the entropy of the universe will be go on increasing. This disorderness of the universe will be go on increasing as the energy conversion is taking place. So that is the about the entropy. Here entropy again, the ordered, disorder. Okay, low entropy, high entropy, highly ordered, highly disorder, more disorder. The solid will be having the low entropy, liquid is having the high entropy. And with the temperature also, we can see that if the lower temperature, then the low entropy will be there, high temperature for the high entropy will be there because of the disordered molecules. That also we can find. Here we can see that one thing, the entropy of universe always increases because of the energy conversion are taking place, energy transitions are taking place. Due to that, always entropy of the universe will be increases. That is about the what is the entropy, and about that entropy we have discussed, and further we are going to find out how the entropy is calculated by using the equation, and the concern to the entropy, the different systems also we are going to take. Thanks for watching. If you like, share, subscribe and comment.